Hi, everyone. Just wanted to take a minute to talk about how to solve inequalities, compound inequalities, and how to illustrate their solution sets. So, as a quick reminder, the two types of compound inequalities are and inequalities and the or compound inequalities. And the and compound inequalities, those are the ones where you have, something like that, one's going that direction, the other one's going this way. And we care specifically about this area where both of them are true. So we're looking in and for where are both inequalities going to be satisfied. The or is saying, I have one over here and I have another inequality, that's this way. And we're saying, oh, this one's true or this one's true. There's that gap in the middle. The and ones, that's the one where you just have the area where they overlap. The or is the gap one. All right. So now that we have discussed that brief overview, let's look at this first one. And as a reminder, you can write and compound inequalities either in this format where we're saying 2 is less than or equal to 4x minus 18, which is less than or equal to 10. Or you could have something where it explicitly uses and. You would have it kind of similar to this format down here. Instead of an or, you say and. The results that you get should be similar. All right, so I wanted to show you this one just because I wanted to be clear. This is essentially two different inequality problems. We're essentially dealing with, this part right here, and then we're also essentially dealing with, that part right there. And if we can do this all in one go, or we can rewrite it. So if we were to have rewritten it, it would be the same thing as 2 is less than or equal to 4x minus 18 and use a different color. 4x minus 18 is less than or equal to 10. So you could do it that way and rewrite it as such. Or what you can do is you can do it all in one go, all right? And I personally like to do it all in one go. It's a little bit of a time saver, but if you are feeling more comfortable with this, go ahead and use that. So I can add 18 over here. And we need to be careful, right? Because this is essentially two different problems. So I also have to add it over here onto the other side of the inequality as well. So I get 20 is less than or equal to 4x, which is less than or equal to 28. All right, so whatever I'm doing to the center, I'm doing to the right and to the left. So when I'm dividing by 4, I'm not just dividing the 20 by 4, or I'm not just dividing the 28 by 4. I'm dividing everything by 4. All right, so I get 5 is less than or equal to x, which is less than or equal to 7. And what the heck does this mean? We're saying that x is in between 5 and 7, right? So anything in between 5 and 7, and we are including 5 and 7 because we have the equal to component as well. So if we were to graph this, and here's 5, 4, 6, 7, 8. Okay, so essentially what's happening here is we're saying at 5 we have our full circle, and at 7 we have our full circle, and we're looking for just what's in between them. So that right there, that is my solution set. Everything in between 5 and 7. If we were to write that using the interval notation, I think that's kind of the nicest way to be able to look at it. We're just looking between 5 and 7. We need to include the brackets, because remember, if we weren't using circles, we could use brackets as opposed to parentheses. So that's how we would do it in terms of interval notation. If you were to use the set builder notation, it would still just be x such that x, it's in between. Okay. See, any of these are acceptable. I really do enjoy this one just for clarity, and I think it helps you out later on when you're dealing with more notational things than when you're dealing specifically just with number lines, but the number line is also helpful to visualize it as well. All right, So that's and. Now let's look at an or problem. So we're solving the compound inequality and graphing the solution. All right. So essentially when we're dealing with or problems, is we're dealing with the problem on the left and then we're dealing with the problem on the right. These ones you can't kind of combine because we're dealing with essentially, right, when we're expecting this, we should have one kind of going that way and the other going that way. So we wouldn't combine these. That wouldn't make sense. So essentially, let's just look at this first part. 2 times 4x plus 3 is greater than or equal to negative 10. So we have 8x plus 6 is greater than or equal to negative 10. Could have divided if I would have rather, but either's fine. So we have 8x is greater than or equal to negative 16, and then x is greater than or equal to negative 2. Right, we're going to divide by the 8. All right, and then we have, so what we can actually do at this point is, I made my number line here. Here's negative 2, here's negative 1, here's 0. Okay, so we are saying a filled in circle there, and we're saying x is greater than or equal to negative 2. Okay, let's use a different color for the other side. Negative 5x minus 15 is greater, is just greater than, not greater than or equal to, just greater than 5. All right, and if we add the 15 to both sides, all right. Now, we are going to divide by a negative here, so we do need to remember to flip the inequality. So I get x is going to be less than negative 4. Okay. So negative 3, negative 4, negative 5. Now, it is an open circle because we're not including, not including the 4. Just 2 out of 5. We're not including the 4. And we are going to the left now. So you'll see here, we're saying this is true in either case, right? If it's true over here, that's fine. If it's true over here, that's fine. If you had ended up, let's say in a scenario, by the way, where you had gotten it like this and it gone like that, this is always going to work, right? So if you had gotten an or, it's greater than or equal to negative 2, or it's less than 4 or something like that, right? That's always going to work. Either one of them is always going to be satisfied at some point. Sometimes both of them are satisfied. And if you ended up with an and problem, this would be one where it's not nicely put together. But if you ended up with it has to be less than 4 and, greater than 6 or something like that, that and there's going to be no solution. So it is possible, but usually what you'd anticipate is with the and, there being that middle section that's shaded in, and with the or, the two opposite ends. All right, now let's really quickly look at how can we illustrate this using interval notation. So we could say that x is an element of, well, over here, we would go from negative infinity over to 4, right? So that still holds. It's a negative 4, I should say. But there's another case where this works, right? And it doesn't matter which one. The or is saying either this side's true or that side's true. We don't care. We don't care which side is true. We're just saying we want one of them to be true. So if we looked on the other side, well, negative 2, that needs to be a bracket, goes off up to infinity. However, we don't care which one it is. So this is part of my solution set, and this part's also part of my solution set. So we're just going to do this little U looking thing here. That's the union symbol. So we're saying it could be from negative infinity to negative 4, or we can say it's from negative 2 to infinity. either one of these is going to satisfy this because we're saying we just need one of them true. We don't care which one. We just need one of them true. And any of these values will satisfy at least one of them. In fact, in this case, we're only ever going to satisfy one of them at a time. All right. So last thing we want to look at really quickly is let's look at a word problem. Most of the word problems that you are going to encounter when you're dealing with compound inequalities tends to be the and problems, because it's a lot of finance situations kind of tend to be, you're in a budget range of, you don't want it to be, too cheap, because then, that might be a different scenario that's going on. But you don't want to be too expensive because then you wouldn't have any money. So if, let's say, you want a really high quality car, right? There's going to be a minimum that you're going to be able to get away with buying, say a Mercedes or something, right? If you're buying like a $5 Mercedes, you're probably going to question something's wrong with that car. But you don't want to spend too much money, or you're going to have no money. So that's kind of why I'm saying there's an and situation that tends to come out more. You're kind of looking for like a minimum to a maximum. Now, an or could take place. I will say that. Usually that's kind of when you're dealing with opposite ends of the spectrum. My brain tends to go to money with these types of problems, and or doesn't always make a lot of sense with that one. But I've seen situations where an or problem could be like the temperature, if you're dealing with states of matter, like it's a gas below this point and it's a gas above this point and a solid below this point, you're solving for where it's not a liquid or something like that. Some kind of situation like that. But anyway, let's go over how we on earth we would actually solve this. So Nadine plans to ride her bike between 12 miles and 15 miles. Write and solve an inequality model how many hours Nadine will be riding. So Nadine will be going at a rate of 10 miles per hour. Right, so we're going at 10 miles per hour. And if I'm going for X hours, my goal is to be between 12 and 15. And in this particular case, it doesn't really matter if we're dealing with greater than or equal to or less than or equal to. I'm going to put the equal to just because it's okay if Nadim rides 12 miles and it's okay if Nadim rides 15 miles. Either is acceptable in this instance. It's not a super crazy situation. Usually it's very explicit about not including it. So in this case, I'm just going to include it. So then we would just divide by 10. And again, just like before, we have to divide both sides by the 10, or all sides by the 10, I should say. So Nadim is going to be riding between 1.2 and 1.5 hours. Okay. So that's all we're looking for in problems like this. I hope this helps you out in terms of solving compound inequalities. All right, let me know if you have any questions. Have a great day.